Hello and welcome to today's webinar. On today's webinar, we will be talking about the 6 factors that can make or break your cloud migration. Today's event is brought to you in partnership with SIOS and produced by Actual Tech Media. My name is David Davis of Actual Tech Media, and I'm excited to be your moderator today. We've got a great topic lined up for you today and a really expert speaker as well. So some really cool content will be found on today's event. If you're interested in databases and high availability, you are in the right place. We are here to get your questions answered. We'll be doing a dedicated Q&A session at the end of today's presentation. And you can find the questions box there on the left-hand side of your audience console. In fact, I can call your attention to it right now. I see many of you already commenting in the questions box. Good morning. Happy Thursday to everyone out there. Thanks for being on the event today. We want to get your questions answered, like I said, and we'll be doing a dedicated Q&A session at the end of today's presentation. So keep those questions coming throughout today's webinar. We also have a prize that we'll be announcing at the end of the webinar. If you're watching this on demand, I'm sorry, the drawing has already occurred. The prize for today is an Amazon $300 gift card. So make sure that you stay to the end for that cool prize drawing. The prize terms and conditions can be found there in the handouts tab. And with that, I'm excited to introduce you to today's expert presenter. That is Mr. Dave Birmingham. He's an evangelist at SIOS, really expert in this topic. Dave, it's great to have you on the event today.
Great, thanks for having me, David. I'm glad to be here.
Excellent. Well, this is a really cool topic. I know a lot of companies out there are struggling, to decide if, when, how to move databases to the public cloud, and high availability is such a critical topic on that. I mean, these critical databases have to be up and running at all times. And so, Dave, I know you've got some cool content around this. Go ahead, take it away.
All right, great. Thanks, David. All right, let's go. So I'm going to jump right into the presentation here. Before I start, I'll just introduce myself a little bit. My name is Dave Birmingham. I'm a Microsoft MVP in Cloud and Data Center Management, and I've worked for SIOS Technology for the past 16 years. So SIOS is a software company that specializes in high availability and disaster recovery solutions for both Windows and Linux. And at SIOS, I help people design and deploy high availability and DR solutions for mission critical applications like SQL Server and SAP and other applications. The majority of our customers recently that I've been helping are deploying their solutions in the cloud or looking to move existing on-premise solutions to the cloud. So today, the focus is really going to be around, not necessarily the migration piece of it, but more of what to plan for in preparation for your migration, what you need to know about running your mission critical applications in the cloud around high availability and disaster recovery. And we're also going to be focusing really exclusively on infrastructure as a service rather than software as a service or platform as a service, database as a service. They're all great topics, but today we're going to be focused really exclusively on infrastructure as a service. And what we're going to look at are 6 factors that I believe you need to consider when planning to move your mission critical database solutions to the cloud. We're going to cover how much HA do I really need, and doesn't the cloud provider do that for me anyway? And what are the differences between high availability in the cloud and what I do today on premises? We'll also cover what I need to know about my licensing options in the cloud. And how much is this going to cost me? Is there any way I can reduce my bill? What about disaster recovery? Do I need to plan for that? And then finally, we're going to talk a little bit about the human factor. What does that mean and why should I care? So the first topic being the level of availability, or factor 1. So let's jump right in. How much availability do you really need? This is the first question you have to ask yourself is how much downtime can you tolerate? The downtime is commonly referred to as how many nines of availability do you need? Do you need 3 nines of availability, 4 nines, or more? Don't forget, downtime can be both planned and unplanned. So make sure you understand whether planned downtime is going to be accounted against you in your terms of any service level agreements that you're responsible for maintaining. Typically, planned downtime and unplanned downtime are both counted as downtime and will be included when measuring your overall availability. Another term you will see used very often is your recovery time objective, also known as your RTO. Your RTO is the amount of time it takes for an application to recover from an unexpected failure. The more nines of availability you desire, the lower your RTO will need to be in order to meet those objectives. So for instance, if you signed up for 4 nines of availability, which equals 1 minute and 1 second of downtime per week, or no more than 4 minutes and 23 seconds of downtime per month, that leaves a very slim margin for error. So your RTO in that environment is typically going to have to be measured in seconds rather than minutes. Another term you will commonly hear mentioned along with RTO is RPO, or Recovery Point Objective. RPO is a term used when planning disaster recovery. For high availability scenarios, your recovery point objective is almost always zero data loss. But for more catastrophic failures that require you to enact your disaster recovery plan, you typically have more flexibility in terms of what is deemed an acceptable amount of data loss. Your company should have a business continuity plan, and the business continuity plan will determine the level of availability that each system needs. And that will impact how you plan for both high availability and disaster recovery. Now, keep in mind, some systems might have a more stringent availability requirements, whereas other systems maybe not as much. And so you will address those systems differently depending upon the availability that the business continuity plan determines. So this slide illustrates the different level of availability protections available to you in the cloud. If we look at the top of this triangle, we have continuous availability, also known as fault-tolerant systems. And these types of systems are not typically available in the public cloud due to the tight integration required between hardware and software. You will commonly find fault-tolerant systems are used in manufacturing areas, security, flight control, etc. So fault-tolerant systems require 5 nines or greater of availability with minimal to no downtime. Of course, these are very critical systems and which will determine that they need that fault-tolerant level. So in the cloud, really the next layer down is where we begin. So the next layer down is high availability. And this is where you'll find most of your mission critical database systems located. High availability in the cloud commonly starts at 4 nines of availability, which again equals to less than 5 minutes of downtime per month. And this downtime not only accounts again for the infrastructure, but also the application itself. So to achieve high availability of mission critical database systems, you typically have to deploy 2 or more instances that are hot standby systems for the primary instance that are ready to take over automatically in the event of a failure of the primary system. So when deploying high availability systems in the cloud, the standby system should always be located in a different data center in the same cloud region. And this is commonly known as an availability zone. So solutions like SQL Server always on availability groups and SQL Server failover cluster instances are some of the solutions that qualify as highly available. High availability solutions not only give you the required recovery time objective in the event of unexpected failures, they also minimize downtime associated with planned maintenance. So high availability solutions commonly allow what is called a rolling update. So rolling update simply means that software updates and hardware maintenance can be done on the standby server without impacting the availability of the primary server. But once the update is applied or maintenance is performed on the underlying hardware, the administrator can do a planned failover so that the previous primary server now becomes the standby server, allowing it to be updated while the original standby server is now the primary server. It is extremely important not to overlook the downtime associated with planned maintenance. Over the lifetime of a system, over the lifetime of a system, planned maintenance is typically causes the lion's share of downtime. Without some sort of high availability solution in place, you cannot eliminate the downtime associated with planned maintenance. The third layer down is what I call just availability. Just availability is a step above infrastructure availability only, with the difference being that we are providing a guarantee of not only the infrastructure, but also the applications that run on top of the infrastructure. When comparing high availability with just availability, the difference is with just availability, there is no hot standby system, which limits your recovery options. The additional expenses associated with high availability cannot always be justified for every system, but these systems commonly need a higher level of availability than what the cloud platform provider provides by default. So while the cloud provider will provide 3 nines of availability when deploying a single virtual machine in the cloud, they do nothing to provide for the availability of the applications running inside the virtual machine. So for those applications that you need both infrastructure availability and application availability, but don't necessarily require high availability and the expense associated with it, you have the option to deploy third-party solutions like the SIOS LifeKeeper single server protection or SIOS AppKeeper. These solutions actively monitor availability of the application inside the virtual machine and take steps to recover the application should a failure be detected. The recovery could be as simple as an application restart or as drastic as the restart of an entire virtual machine. At the fourth layer down, we see the default option for most cloud providers. It's what I call infrastructure availability only. Most cloud providers will guarantee a single VM that is deployed will be available 99.9% of the time. So this guarantee is usually expressed in the form of a service level agreement that says if your VM is not available for at least 99.9% of the month, you can submit a claim to be reimbursed for a portion of your cloud expenditure. And that amount will be the amount that will be reimbursed depends on how much downtime you have experienced. It typically starts at a 10% refund and goes all the way up to 100% refund if your VM was only available 95% of the time of the month or less. So what that means, if you were down for over 36 hours or more in that given month, your SLA should say that you should be reimbursed 100%. But remember, it's incumbent upon you to request that refund should your SLA be exceeded. And finally, for instances where you need no availability, cloud providers offer something called a spot instance. As you can imagine, cloud providers typically have excess resources available to accommodate spikes in demand and to leave room for growth to sign up new customers. So they will allow you to use this extra space at a spot price, meaning that you pay what you think it is worth. And as long as the resources are available and no one is willing to outbid you or pay more, you can use those resources. You can get these resources very, very inexpensively, but the downside is there is zero guarantee that they will be available. And in fact, they can pull the rug right out from under you at any given time. So this means your VM and any data you had on that VM are gone forever. Of course, these spot instances do not qualify for production usage, but maybe for test and dev or other scenarios where reliability is not a factor, you could save money on your cloud spend. This slide illustrates what we spoke about in the previous slide. So you can clearly see where the cloud provider's responsibility ends and the customer's responsibility begins. Cloud providers support the platform, but the user is responsible for everything they build on top of that platform. The other thing you should remember is that in order to qualify for the 4 nines of availability, you must deploy your virtual machines in different availability zones or different data centers. We talked about that earlier. So there's no getting around that requirement if you want to qualify for high availability or the 4 nines. So this means that solutions that you deploy must support cross availability zone failover. Well, this eliminates some solutions such as Microsoft Storage Spaces Direct or even the new Azure Shared Disk as viable options for true high availability, because both of those are limited to deployments in a single availability zone, which would eliminate them from being qualified for 4 nines of availability. So again, carefully read your service level agreement, as they will vary between cloud service providers. One thing I haven't discussed yet is something I like to call the availability chain. I've recently written about the availability chain in my blog, Clustering for Mere Mortals. In essence, your availability is only as good as the weakest link in your chain. And if you have multiple weak links, your downtime will increase exponentially. So if you look at any application and you look at all the components between that application, we start all the way to the left, and you have a client. And this is going to be different depending upon your application and all the components involved. But let's say I have a cloud service that I want to offer, and I'm sitting in my office here in New Jersey, and I want to consume that service. So I might have to connect into the cloud over ExpressRoute. Well, guess what? ExpressRoute only has 99.95% availability. So immediately, my application is no longer 99.99% available. It's now 99.95% available. And then from there, I might have to go hit a load balancer to hit some web server farm. That load balancer has 99.99% availability. Well, that's good. But again, you kind of have to combine all those liabilities. So you might think you have 4 nines, but again, you go through the load balancer to the web farm, to another load balancer, to the database, and then let's not forget about all the dependent services like Active Directory. You need to make sure you're providing availability for Active Directory, your DNS servers, your storage. If you look at your SLA, typically the storage itself has a different SLA. So many cloud providers will give you SLA for compute, but then the SLA for the storage might be less than compute. And if your storage is not available, it doesn't really matter if your VM is up and running, because if the storage is not there, you're not serving any databases. So just something to be aware of. You need to identify those weak links and realize that the more weak links you have, the lower your availability is going to be overall. So let's, David, if you could pull up the first poll. I'd like to get some feedback from the audience here.
Absolutely. Yeah. We've just brought up this poll on the screen. I want to call everyone's attention to that says, how much downtime can you tolerate per month for your mission critical database instances? And you brought up a great point, Dave. I bet a lot of folks out there don't know about and didn't know about it, is that these different pieces that make up the cloud infrastructure can all have different SLAs. The load balancer, the storage, all of these, the compute, all these can have different SLAs. So really cool stuff that we're learning about on the event today. I did have a question for you when you were talking about a shared storage. Let's see. Sorry, we haven't talked about that yet. We're about to get to that. But one of the questions I did want to ask you is, when we talk about high availability here, are we primarily talking about at the database application level? Is that what the solution we're learning about today does, or it doesn't really provide high availability for, say, the compute. That's provided by the cloud. Is that
Yeah,
how it works?
exactly. Right. So if you read your service level agreement from the cloud provider, they're guaranteeing the infrastructure, whether it's the 4 nines if you deploy across availability zones, which essentially is just dial tone. They're giving you making sure that your VMs are up and running, but they're not guaranteeing anything about what you have running on those VMs. So whether it's a database server, a web server, whatever it might be, they're not making any sort of guarantees about the application or service that you're providing. So you need to take additional steps. And that's where SIOS comes in. We have solutions for Windows and Linux that go and take the next step and actively monitor those applications to ensure they're highly available.
Excellent. Excellent. Well, very cool. All right. Let me just share the results of this now for everyone out there. It looks like 37% said 5 nines is what they could tolerate. Below that, it was 4 nines, all the way down to just 12% that said they could tolerate 3 nines. What's your take on that, Dave?
That's really interesting. So the 5 nines or fault tolerant systems are, very expensive. So I'd be curious to know what you're doing today on-prem if you're running fault tolerant systems. And then what do you think about moving to the cloud? Do you think you're going to be able to continue to get 5 nines? That would be a challenge. So I was kind of curious to see that was the most prevalent. But 4 nines obviously is high availability. Most people will want that. And the rest, yeah. I mean, again, some systems are going to be very business critical, others not so much. And so that's good information.
Absolutely. Yeah. And you talked about, I mean, we all want 5 nines, of course, but are we willing to pay for it? And, where can we get the best value? Where should we run our application? And so why don't we move on to that and talk about on-prem versus cloud?
Okay, excellent. So factor 2, we're talking about high availability on-prem versus cloud. High availability solutions in the cloud are not always the same as high availability solutions on premise. So on premise, you're likely to have a mixture of availability solutions. So you might be using something like VMware HA or Hyper-V failover clustering to provide infrastructure availability for all your applications or all your Windows and Linux and anything else you run in a virtual machine. But for other applications that require both infrastructure and application layer of availability, again, you might be using things like SQL Server failover cluster instances or always on availability groups. And that gives you the next level of availability that provides both infrastructure and application availability. So as you move into the cloud, you will encounter some challenges to each of those solutions that you must address in order to achieve your availability goals. So your the viability of your high availability options for on-premise includes some of the following, right? We mentioned availability solutions like VMware HA and Hyper-V clusters that give you the infrastructure availability, but again, do not address the availability of the applications and running inside the virtual machines. And so for that reason, I don't really consider those solutions truly highly available. But some of the oldest and most well-known high availability solutions would be Windows Server failover clustering, for SQL Server, FCI, and other shared storage-based clusters. So on Linux, some open source solutions, but all on-premise. The cluster, when I say, or SAN, would really be kind of like the central heart of your clusters where all the data resides. It's a single point, I would call it a single point of failure. I mean, SANs are very redundant, but your data does live in that one shared storage location. So in the Microsoft world, again, SQL Server failover cluster instances, We have 2 or more nodes connected to that shared storage device. And again, it's been around since SQL Server version 7 and so commonly used today. Again, one of the limitations of shared storage cluster is that the cluster nodes must all reside in the same data center. That's because they all, you must have an extremely low latency connection to that shared storage device. So when you look at moving clusters that span multiple data centers, shared storage really doesn't make a lot of sense. So the third option you commonly see that overcomes that limitation are some of the application-specific availability solutions. There are solutions such as the SQL Server always-on availability groups, or before that, SQL Server database mirroring. Or even some people consider log shipping. I don't consider it highly available, but it's one way to get multiple copies of your data spread across multiple SQL Server instances. It gives you some level of availability. And then finally, the third option for high availability on-premises today, again, includes third-party application solutions such as the SIOS protection suite for Linux and Windows, and something we call Datakeeper Cluster Edition, which extends Windows Server failover clustering so you can build SANless clusters. So these solutions offer alternatives to application-specific solutions or traditional shared storage clusters that overcome some of those limitations. So when we move to the cloud, you will soon find out that high availability options become a little bit more limited. So you no longer have access to the hypervisor. So things like VMware HA and Hyper-V clusters are no longer an option. Now, the cloud provider does offer 99.9% of availability for a single VM, but you're at the mercy of the cloud provider to ensure that they meet that service level agreement. And when you move to the cloud, you will soon find out that shared storage clusters are also no longer a viable option. With the exception of the recently introduced Azure shared disk resource, cloud providers typically do not offer shared storage options that can be used in a cluster. Now, there's a problem with any shared storage offering, including that new Azure shared disk, is that it does not support cross-availability zone clusters. And as you might recall, as we discussed earlier, in order to qualify for that 99.99% availability, less than 5 minutes of downtime per month, your clusters must span availability zones. And even solutions like Microsoft Storage Spaces Direct, which can in some places replace the need for shared storage, it does not support cross-subnet deployments, cross-availability zone deployments. So once again, there's really no native offering to support shared storage clusters in the cloud that qualifies for that 4 nines of availability. Now, application-specific availability solutions like the SQL Server always-on availability groups are still viable in the cloud. There's nothing prohibiting you from deploying always-on availability groups with synchronous replication between the nodes that reside in different availability zones. So if you're currently using SQL Server always-on availability groups on-premise, it is highly likely that you will want to continue to use those solutions in the cloud. However, if you've not used always-on availability groups, you may want to look at your alternatives to make sure you're making the right decision. So let's pull up the second poll here, David, if we could do that.
Absolutely. Yeah. The poll on the screen for everyone out there I want to call your attention to is, what do you use for high availability today? And this is a single, we've got this set up as a single select. So I would say select the high availability option that you use the most if you use multiple. And I will share the results of this with you, and you can see how you stack up with your peers on today's event. So Dave, this is really interesting. So when choosing between on-premises versus cloud, I mean, obviously there's a lot of different factors to be involved in that decision. Today, we're just kind of honing in on the high availability factors. Is that right?
Yeah, right. So we're talking about high availability, and for those people that are doing hypervisor-based availability, they're getting that by default. They spin up a virtual machine, and whoever is your VMware administrator or your Hyper-V administrator, they've built some level of infrastructure availability, so you're going to get that automatically, and that might be good for some applications. But the problem with that hypervisor availability is it doesn't account for unplanned downtime. I'm sorry, it doesn't account for planned downtimes. It's a single VM. If you need to do maintenance on that VM, you got to schedule downtime. It also doesn't do the application level monitoring. So if SQL Server gets hung up, something's going on, you won't have a failover, and there's no hot standby that's going to be able to take over that workload. So you have to fix that single instance. So that's going to cause more downtime. So people typically know that, for their truly business critical applications, they're going to have to do something above and beyond that hypervisor availability. And that's where we see the remaining three options, which make up 50+% of the deployments, whether you're using shared storage clusters or application specific solutions like always on availability groups, or again, third party solutions like SIOS Datakeeper. They're getting that HA solution at both the application and infrastructure layer.
Excellent. So let me share the results of this poll. And it looks like 28% are using shared storage clusters, followed by 23% who said they're using hypervisor-based availability. What do you think, Dave?
Yeah, I mean, that's pretty much what I expect. I'm not sure what other are doing. They might not be doing HA at all, and that's okay. I mean, there's some environments that don't really need to be much more available than having a good backup, right? And if you can get things back up and running in a day or two, boss is happy, and so you don't have to incur the expense of high availability.
Yeah, absolutely. All right, excellent. Well, thank you everyone for your feedback. Let's move on now. Let's talk about factor 3 when it comes to the 6 factors that can make or break your database cloud migration, and that is software licensing. Dave, what do we need to know?
Yeah, thanks. So software licensing, let's take a look at this here. One of the first things you need to consider for software licensing is how you're going to pay for your SQL Server license or any other application. Obviously, I'm using SQL Server very often in my examples because I deal a lot with SQL Server. But if you are doing SQL Server, you have two options. You have the SQL Server pay-as-you-go option, where you're renting the services or bring your own license, right? So let's take a look at the benefits of each model. So with the pay-as-you-go model, the first benefit is that you only pay for what you use. That means you're only paying for that license when that virtual machine is running. So if you have some workloads that don't need to run 24/7, you can schedule your virtual machines to shut down after hours. And during that time they're shut down, you're not paying for that SQL Server license on that instance. The other benefit is if you decide to increase or decrease the instance size, the cost associated with SQL Server licenses will also increase or decrease proportionately. So this is an excellent benefit if you're not quite sure what your load might be, or if you have certain times of the year or month where you need to increase the capacity of a SQL Server instance to handle additional workload. So of course, if you're using pay-as-you-go, at any given time, you can choose to deploy the latest version of SQL Server. Or if you need an earlier version of SQL Server to support a legacy application, those versions are available as well. So it's kind of like a smorgasbord. You eat all you can, what you want. You have lots of options, right? Then there's there's of course the expense of a SQL Server license. So if you can spend hundreds of thousands of dollars on SQL Server licenses if you bring your own license. So instead of incurring all that expense up front as a capital expense, you can simply rent SQL Server licenses monthly and get them charged as more of an operational expense. Now, if you look at the benefits of bringing your own license to SQL Server to the cloud, the first thing you'll see is that over time, it will be less expensive. In many cases, it will take just 10 months to recoup the initial cost of your SQL Server licenses. So you really, have to do the math, the one-time upfront expense versus spreading that expense over time. Another benefit of bringing your own license is that if you have software assurance for that license, you may be entitled, you are entitled to a free secondary server as well as a free disaster recovery instance. So this can be a huge cost savings compared to pay-as-you-go licenses, which require you to pay for licenses on all the servers, even if they are passive servers in the cluster. And Microsoft made that change last year, where prior to last year, they would give you a free secondary server, but they've added a free DR server as well. So it's really great, especially if you're doing like 3-node clusters for HA and DR. And then finally, if you're planning on retiring your on-premise instance of SQL Server, and you have an enterprise agreement with software assurance in place, you may qualify for what Microsoft calls license mobility. That means you can transfer your existing license from on-prem into the cloud. So let's talk a little bit about license mobility. If you have a volume license of SQL Server on premises today and you've maintained software assurance, then you're likely eligible to move those licenses to what Microsoft calls an authorized mobility partner. So the good news is all three of the major cloud providers, Azure, AWS, and Google, they're all authorized mobility partners. So there's a process you must follow before you can take advantage of license mobility. So if you're going to want to make sure you visit that URL at the bottom of this slide and follow the steps as described so that you can take advantage of license mobility. Now, if your SQL Server licenses do not qualify for license mobility, then you're going to be stuck with either using pay-as-you-go licenses or purchasing new licenses for use in the cloud. Now, if you're going to be purchasing new licenses, now's the time to decide whether you need SQL Server Enterprise Edition or SQL Server Standard Edition. So let's take a look at the costs associated with each edition. Now, again, if we're talking about high availability in the cloud, it really comes down to two options. You have the SQL Server Always-On Availability Groups, which is going to require the Enterprise Edition, and then you have the SANless cluster with the SIOS Data Keeper, which can work with any version of SQL, whether it's the Standard Edition or Enterprise Edition. And so this chart here illustrates the cost savings. So in the chart, you have the green bar and the blue bar. The blue bar is the always-on solution, and the green bar is the SANless cluster solution with Data Keeper. So as you see, this is a 2-node cluster, and as the number of cores increases, of course, your SQL Server licensing is going to increase, and your associated cost savings also increases. Where if you see all the way to the right, that is the price of of trying to cluster a 24-core server. You'll see in that scenario, you're going to have a 71% cost savings using the SANless cluster with SIOS Data Keeper versus the always-on availability group solution that is going to require the SQL Server Enterprise Edition. So if you're not locked in and you haven't made your decisions yet, you're definitely going to want to run the numbers and see what makes sense for your environment. And again, it's not all just about cost. With the SANless cluster, you're getting a true SQL Server FCI or failover cluster instance. So you're going to have some technical benefits as well, such as not being limited by the number of databases you can run. Also, it supports distributed transactions. And if you're configuring things like transactional replication, we have subscribers and publishers, all that works beautifully with a failover cluster instance versus the always-on availability group solution, which, again, depending upon the version of SQL, is going to have some limitations. So David, let's put up this third poll here and see what people are planning to do or are going to do.
Absolutely, yeah. So the question on the screen is, do you plan to bring your own license to the cloud or use pay-as-you-go licensing if you move, or assuming you're moving or considering moving to the cloud with your database? So I'll leave that up here for a moment for everyone to answer, and then we'll share the results. Dave, when you talked about the solution here and the different database pricing models, could the SIOS solution potentially pay for itself and provide better availability?
Yeah, absolutely. I mean, you saw the difference. It pays for itself on day one, right? And when you compare the always-on availability groups in Enterprise Edition versus the Salesforce Cluster and SQL Server Standard Edition, yeah, right out the gates, you're going to have a 70% cost savings. And then over time, if you're maintaining software assurance accounts for about 25% of your SQL Server license. So if you're paying software assurance on Enterprise Edition, you're paying more probably just for software assurance alone than you are for the entire DataKeeper SandList cluster solution on SQL Server Standard Edition. So yeah, it pays for itself immediately, and the cost savings just grows exponentially year over year.
Very impressive. There's not a lot of solutions out there like that pay for themselves on day one. So very cool, very interesting solution. The response here to the poll was relatively evenly split, with 56% saying BYOL and 43% are using pay-as-you-go. What do you think, Dave?
Yeah, I mean, that kind of jives with what I see out there. Bring your own license certainly makes sense, especially if you can utilize license mobility. Even if you can't, again, over time, to bring your own license is going to be a less expensive solution. But if you don't want that upfront expense, then pay-as-you-go is a great option for you.
Excellent. All right, well, let's dive a little bit deeper into cost now. Back to you, Dave.
All right, great. Thanks, David. So cost savings, factor 4. So your first cloud utilization bill might cause a bit of sticker shock if you're not prepared. However, there are some common sense practices that you can put into play that will help you save on your cloud utilization. This is especially important when deploying highly available systems, since by nature, they consume more cloud resources due to the redundancy of systems that are required. So some friendly cost savings advice I've learned over time. This shouldn't be news to you if you've been doing any sort of research, but if you haven't, these are some great things to take into consideration. So first off, when purchasing your virtual machines, you have the option to enter into 1 or 3-year contracts. And by committing to these reserved instances or contracts, you can save up to, and this comes direct from some Microsoft documentation, but you can save up to 72% on the total cost of running that virtual machine. While you're committed for the duration of the contract, there generally are provisions to get out of the contract with a termination fee. But if you have any assurance that you will be running these instances for a year or longer, it certainly makes sense to purchase reserved instances. Something you may or may not realize, but you should also choose your region wisely. So when cloud providers have multiple regions, so when choosing a region to deploy into, again, you have multiple options, but you may be limited. Maybe that you might have to keep your data within your country of origin, or if you have some flexibility, you can save up to 50%. This is my own personal research, but up to 50% by deploying into a region that is less expensive. The prices fluctuate over time from region to region, but at the time that I did the research for this presentation, it seemed like, at least at Azure, the least expensive region was US East 2, and the most expensive region was West Europe at almost twice the expense. Your cloud provider should provide this information to you. I know Microsoft has an updated list available that they keep updated on a pretty regular basis. Right sizing your instance is probably one of the best features of the cloud, is that ability to optimize your instance size. So if, let's say you start with a size of a 2x, right, and find that the instance isn't quite big enough to keep up with your workload, you can simply increase it to a 3x size in just a matter of a minute or two. But of course, that 3x size is going to cost more than the 2x size. But if you have flexibility, should you need it. But more importantly, if you have over-provisioned your server, you want to identify those servers and right-size them so that you're not paying more than you need to. Now, when it comes to high availability configurations where you have an active server and a passive server, you may have the option to undersize your target server. Again, under normal circumstances, the target server or passive server will not be running any applications. But in the event of a failover, the target server can quickly be resized to the appropriate size to run the workload it is expected to run. But of course, that resize will take a minute or two, so it will impact the recovery time objective. But the cost savings can be significant over time if your recovery time objective will allow for that extra time. Another important thing to keep in mind is to identify underutilized resources, right? So just like virtualization, the cloud is susceptible to server sprawl. And you will want to make sure that you stay on top of this and identify underutilized or abandoned resources. So you may be surprised to know that you're paying for storage even though the virtual machine has been stopped and you no longer need it. So take advantage of that and get rid of that server sprawl. And then, of course, you can turn off unused resources. So if you have servers that are only utilized during business hours, then turn them off after hours. There's no reason for you to pay for those resources that are just sitting there idle. David, let's put up this fourth poll. And I know we got about 10 more minutes before the top of the hour, so let's try to get through the last two factors before the top of the hour if we can.
Absolutely, yeah. So the poll on the screen here is, would you be willing to sacrifice some of your RTO if you could save 75% on the cost of your secondary server in a high availability configuration? It's a simple yes or no answer there. And Dave and I are watching the horse race on the screen here to see which one comes out ahead because it's close. Dave, one of the questions I had that came in here, they're asking about when you say host-based solution, what does that mean exactly? Does that mean it's operating system dependent, or it's like an application that runs on the host?
Yeah, I mean, the host-based solution, it just means that the software runs on the host. And we're going to talk about replication. A lot of times we talk about host-based replication versus storage-based replication. So there, some of the old SANs or current SANs, they provide replication at the storage layer. For host-based solutions, they're going to give you that replication at the host layer. And it will be dependent. Windows solutions typically aren't going to run on Linux solutions, but SIOS has a solution that runs on both Windows and Linux called DataKeeper.
Excellent. So the answers here came in with 72% saying yes, they would sacrifice. What do you think, Dave?
Yeah, I mean, sure. I agree, especially if you, money is always king. So that's good information All right. Well,
Excellent.
let's forward here. Talk about Factor 5, disaster recovery. And for disaster recovery, of course, you're deploying mission critical applications to the cloud, so you may wonder whether or not you need to plan for disaster recovery. But why would you wonder? Of course, you need to plan for disaster recovery. The great thing about the cloud is that there is the infrastructure for multiple data centers across multiple regions is already in place, so you don't have to worry about building a disaster recovery site. The cloud vendor has already done that for you. However, it is up to you to take advantage of that infrastructure that's already in place. And so, just like high availability, there are a few options when it comes to disaster recovery. The high availability solutions we discussed, including DataKeeper and always-on availability groups, can also be extended, meaning you can replicate asynchronously to a third node in a different region. And although you might think it's unlikely for both data centers or both availability zones in a single region to go down at the same time, it has happened. And so in those cases, you want to be prepared should you find yourself in that situation. So now, but in addition to simply extending your high availability solutions, the cloud providers will generally also offer other services. Disaster recovery is a service that can also assist in both your database and your other servers. Azure has the Azure Site Recovery, AWS, Cloud Endure, and these solutions are simply you pay for as a service. They replicate the entire virtual machine continuously from one region to another. And so in the event of a disaster, you can spin those virtual machines up. They usually incur a higher recovery time objective and a higher recovery point objective than the other solutions like DataKeeper or always on availability groups. But it is a good solution for some servers that don't require those stringent recovery time and recovery point objectives. Let's put up this poll number 5, and we're going to, we're going to finish out the presentation and try to get to as many questions as we can here.
Excellent. So the question on the screen is, in your cloud deployment, do you plan to use a secondary region for your disaster recovery? Again, simple yes or no, and we'll share the results of this one before we move on to the final factor, factor 6. So while everyone answers this, there's a question that came in. They're asking, can this solution help me to move my applications and databases to the cloud without having to refactor and redesign them?
Yeah, absolutely. I mean, if you're using all failover cluster instances today on-prem, then you might be scratching your head saying, well, how can I do that in the cloud? You might not have realized that you can do that. And so the SIOS DataKeeper solution basically lets you take your existing SQL Server failover cluster instance and move it to the cloud, so you don't have to refactor or rethink high availability.
Excellent. So the answer to this one, 56% said yes.
Okay.
They do plan to use a secondary region. Yeah. So yeah. Very nice. Very good insight.
Yeah, it's there.
Thank
Take
you,
advantage. And so finally, 5 minutes left. We're going to talk about factor 6, the people. So as you transition to the cloud, you'll find that your role or the roles of your team members may change. New team members may be added, and managing cloud resources is entirely different than you're accustomed to in your on-premise data center. So network, storage, compute, security are all now just widgets that the cloud provider rents to you, and you're responsible for the proper configuration and management of those widgets. The whole concept of infrastructure as a service is completely different than on-prem data centers. However, at the end of the day, you still have to manage your operating systems and applications as you do today on-premise. So it's important to understand who is assuming the cloud roles so that you know who to talk to when to get things working properly. Not only is it important for you to know who to talk to, but it's also important to have an open line of communication with those individuals. If you have to contact 3 different people to deal with storage, security, and compute, then you want to make sure all those individuals are readily available to you when you need their assistance. And that goes both ways. You want to make sure to keep an open door and be available when you're called upon to assist with your role in your cloud environment. Now, another factor I want to squeeze in here is the importance of having a test environment. I can't stress the importance of this enough. You want to avoid unexpected downtime or outages that may occur. If you think you're only making a minor change or installing a minor update, you don't want to be the one left held responsible for causing downtime. So there's no reason why you wouldn't have, especially with the cloud, a test environment spun up, ready to go to do all your testing before you deploy in production. And then it's also important to test your HA and DR periodically. So if there's a problem with either system, you don't want to have to find out about it unexpectedly. You want all hands on deck, and ideally, you'll do that testing at the most opportune time for the business, not during the busy season or at the year's end when people are trying to close out the books, and also make the test as realistic as possible. So you should automate as much as possible and document well so that even your most junior team members could recover on their own if they had to. And speaking of documentation, let's talk about the run book. And this is critical, a part of your documentation. So the run book is a living document that is readily accessible to your entire organization, and it contains every piece of information that is relevant to your cloud environment. So when things change, whether it's security groups, or storage accounts, virtual networks, or anything else, those changes must be documented in this run book. And having access, the whole team having access to this run book is vital when troubleshooting issues that may arise in your environment. So without this run book, your troubleshooting exercise becomes much more complicated. And in conclusion, just under the wire here, we talked about defining your availability requirements, and they could be different depending upon the different applications you support. We talked about the differences between on-prem and cloud HA solutions. We talked about what you need to know about software licensing, license mobility, rent or pay-as-you-go, bring your own licenses, your cost savings opportunities, and great information. There's lots of white papers out there to help you save money in the cloud, the importance of having disaster recovery, and then finally the people factor. And so let's put up this final poll. And again, I want to thank everyone for attending today.
Absolutely, yeah. The poll on the screen there for everyone is, would you like to learn more about how SIOS can help you provide HA and DR for your business critical cloud deployments? Simple question. Let's take some questions here from the audience. We have maybe a minute left. So let's see, one of the questions that came in is, what's the easiest way to test this solution, Dave?
Yeah, reach out to us, and we have a contact at the end of the presentation. Reach out to us. We can get you a trial license, and you can, test it. You'll have access to someone like myself if you have questions, help you get up and running. It's pretty easy though, so you shouldn't have any problems. And it's also available in the marketplace in AWS and Azure, so you can spin it up, pay as you go, and test it that way as well.
Very cool. Yeah, it sounds super easy to test. I did not know that it's in the AWS and Azure marketplace, so that's very cool to know. And it's a pay-as-you-go, pricing model. So thank you, everyone who responded to the poll question there. Let me go ahead and just bring up the final contact info here on the screen. Of course, for more information, you can visit the SIOS website. Phone numbers there. Just give them a call, and actually, if you put that email there in your web browser, in your email client, you can shoot off an email and set up a demo. We will, of course, be reaching out to anyone who expressed interest in additional information. But Dave, it's been really great having you on today. I learned a lot. I'm sure the audience did as well about, the factors that can make or break a cloud migration, specifically to databases and high availability. So really interesting stuff. Quite a few comments have come in. Troy just said he really enjoyed the presentation. Thank you. We appreciate that, as did quite a few others. So before we go, I want to announce the winner of today's Amazon $300 gift card. That's going to Mike Borgen from Illinois. Congratulations. We'll reach out to deliver that gift card. And thank you to SIOS for supporting today's event. For more information, just check out the SIOS website there, also in the AWS and Azure Marketplace. Visit those marketplaces and download the SIOS solution for yourself to implement the best and sounds like the most affordable option for high availability when it comes to databases in the cloud. Thank you, everyone, for joining us. We'll see you next time. Have a great day.